Hello guys, and welcome to another video teaching Nogops. Today we're going to be doing organic chemistry. This one's going to be a bumpy ride, so let's give Nogops her protection goggles. She's going to get protection goggles today. If she wants to be a chemist, she has to have protection. Alright, so hydrocarbons. What are hydrocarbons? Hydrocarbons are organic elements, and the difference between organic and inorganic elements is that with organic elements, it's going to be carbons and hydrogens, and sometimes we can see oxygen, sulfur, nitrogen, or chlorine, also fluorine, bromine, and iodine. And basically what a hydrocarbon or organic element is when we have a chain of carbon and hydrogen atoms. So we know that one carbon atom can make 4 bonds, and one hydrogen atom can only make 1 bond. So if we want to put these two together, one carbon atom would bond with 4 hydrogen atoms. So they'd make a bond here, a bond here, a bond here, a bond here, and this is stable. So most of our hydrocarbons are going, or carbon compounds, what we call them, they're going to be based off of this, the fact that carbon can make 4 and hydrogen can make 1. So we have different kinds of elements, of carbon-based elements. There's 3 that we're going to focus on in this video, and we'll do the rest after. But we will start with our alkanes. And then we also have our alkenes. And then finally, let's move her. We are gonna have our alkynes. So, alkynes. Perfect. So, let's start with our alkenes. Our alkanes. So alkanes are formed, all of these 3 are formed by a continuous chain of carbon atoms. And all of these things, we're going to go into namings a little bit more into detail later, but all of these use 2 kinds of names. They use the IUPAC naming or the common namings. And for alkanes, the names are going to end in ane. So when you see a compound and it ends in ane, you know it's alkane. And it also uses the Greek prefixes to name the carbon chains that, depending on the numbers that there is. So we have them right here. So basically, depending on the number of carbons you have in a chain, it's going to be associated with a prefix for that chain. So if you have 1 carbon, it would go meth. 2 carbons, eth, and then you just keep going down that line. So for example, if we have an alkane that is something like this. So we have a carbon here, and this line represents a bond between the carbon and another carbon here. And remember, carbon is going to be bonded to 3 hydrogen atoms. Since the carbon can make 4 bonds, we already have 1 bond between these 2, and then the other 3 are going to be with hydrogen. So with this one, when we want to know what name it is, we're going to count how many carbon atoms we have. So we have 2 carbon atoms. So we're going to go up here, and we're going to see 2 uses the prefix eth. So we know that this is going to be eth. And since all alkanes have the ending ane, we're going to end it with ane. So we know that this compound is called ethane. So that's an alkane. Now, if we want to move on to another thing in alkanes, it would be something that is called a cycloalkane. Cycloalkane. And what it is basically when we have a chain of alkanes that are cyclic, or that are connected together. So it's not an open chain, It's a closed chain. So for example, if we go up to here and we have something like this, so we have, okay, and let's do these bonds here. So if we have something like this, and we're going to use our naming rules right now. So we have 3 carbons. If we go up here, 3 carbons is pro. So we go back here. We know this is going to be pro. And it's an alkane, so it's going to end with ane. So see how this is just a straight line? Now if we do this exact same formation except down here, but we have it like this, like that, and then this has an H2, 2 H's, and this has 2 H's, and this has 2 H's. This right here would be a cycloalkane. So how do we go on with naming that? Pretty similar rules. We count how many we have, so we have 3. We know that's going to be prop, and then it's still an alkane, so it's going to have the ending ane. But how do we differentiate that one down there with this one up here? Is we just add the prefix cyclo to the beginning. So this would be cyclopropane, and that one would be propane. So that way we know that this one is cyclic and that one is not. And yeah, so there is something that we call substituents, and this is going to apply to all of them, not only alkanes, but we'll get them started before we move on to the other ones. So a substituent is basically they are atoms, or they could be a group of atoms that are attached to the carbon chain. So imagine the carbon chain is like a Christmas tree. These are going to be our ornaments on the Christmas tree. So they can include 2 types. So they can be halo groups or alkyl groups. So our halo groups are going to include F, Br, Cl, and they all have their own they all have their own prefix. So this one's going to be fluoro, bromo, chloro, and ido. And then our alkyl groups are going to be very simple. They're just going to be the number of carbon atoms with the ending -il. So it's just going to be how many carbon atoms we have, find the prefix, and then add -il to the end. That's it. We'll do more examples with it. So these are the substituents that we could have: halo substituents or alkyl substituents. So what does this mean? Before we move on to substituents, there's one more thing that we need to know, is that there's different ways that we can draw our carbon chains. So the one that showed up here would be the uncondensed line formula. And if we want to condense it a little bit more, so I'm just going to redraw it down here for propane. We had 3 carbons. This one has 3H, this has 2H, this one has 3H. So if we want to condense this a little more, we can write it in a more condensed form like this: CH3, CH2, CH2. Sorry, CH3. So this carbon has 3 H's, so 1 carbon with 3 H's. This carbon has 2 H's because it already has a bond here and a bond here. So it's going to be CH2, and then 1 C and 3 H's. So this would be the condensed structural formula, but it can be even more condensed than that. Or no, this would be the condensed structural formula, but we can also do something called the molecular formula. The molecular formula is when you just add everything up. So in total we'd have 3 carbons, and then we have 3, 2, and 3, so it's going to be 8 hydrogens. So we can represent it that way, but we can condense it even more by doing something called the line angle formula. And the line angle formula is when we draw lines that represent the how many carbon atoms we have. So if I have 1 carbon atom, it's going to be a small line. If I have 2 carbon atoms, it's going to be a long line. And the ends of these lines are going to be carbon atoms. So if I have 3 carbon atoms, we will draw 2 lines. We'll have 1 carbon atom here, 1 carbon atom here, and 1 carbon atom here. So this right here would be propane. So, back to the substituents. When we have substituents, now for the cycloalkanes, when you want to draw the line angle formulas, it would just be like for cyclopropane, it would just be like this. You don't have to add C or H or anything. It is assumed that it is there. So, for the substituents, we would see something like this. We'll start with the structural line formula. So let's say we have something like this. We'll do it the condensed one. And then we have a line from here that looks like that. So what would this be? So to figure it out, we're going to start by figuring out what is our parent chain. Our parent chain is going to be the chain with the most carbons. So this one has 3 carbons, so we're going to go with that one. The next thing we're going to do is we're going to number the chain with keeping it in mind that we want our substituent, so this one, to be the lowest possible number. So since this one is in the middle, it doesn't really matter, but we'll do another example where it does matter. So we can go 1, 2, 3, or we can go 1, 2, 3. You can pick the order depending on where you want your substituent to be. But let's just go with this one. So we have identified our parent chain, or our longest chain, and we have numbered it. Now let's start naming the parent chain. So this has 3, so it's going to be propane. And now we need to identify what position the substituent is in. So we can see that the substituent is on the second one. So we're going to add a 2 here. Now all what's left to do is to identify what the substituent is. So it is not a halo group because it's not any of these. If it was one of these, that line up there, instead of saying CH, it would say like an F, or it would say like Cl, but it's not. So we know it's not a halo group, so it must be an alkyl. And for alkyls, it's just how many carbons there is with the yle ending. So we have 1 carbon, go up to our prefix chart, 1 is meth, so you know that this is meth. And then we have to add that yle ending, so it's going to be methyl. So we just have to plug that in. And this compound would be called 2-methylpropane. 2 telling us where the substituent is. It's on the second carbon. Methyl telling us what the substituent is. And then finally, propane telling us what the main chain is. So that is alkanes and substituents. Let's go back up here and go over what alkenes and alkynes are. So we saw that with alkanes, there is a single bond between the carbon atoms here. Only one bond. With alkenes, we're going to see 2 bonds. So it's going to look something like this, meaning that this carbon atom can make 2 more bonds, and this carbon atom can make 2 more bonds, because it can usually make 4. 2 are already taken here, so it leaves you with only 2 left. And alkynes, similar enough, they can make 3 bonds, which means we only have 1. It can make 1 bond here, and it can make 1 bond there. So that's the difference between alkanes, alkenes, and alkynes. Alkanes is only 1 bond, alkenes is 2 bonds, and then alkynes is gonna be your 3 bonds. So with alkenes, there's some specific things that we need to know. First, we're gonna start with the names. Everything that we mentioned here is the exact same, except the ending, it's not gonna be ain, it's gonna be een. So if we have, for example, something like this, we can automatically see that there's a double bond. This automatically makes it an alkene. Doesn't have to be a double bond across the entire chain, just need one double bond to tell us that this is an alkene. And so this would be called, so we have 3, so it would be prop, and then it's gonna have the ene ending. That lets us know, okay, this is double bonded. Now, yeah, the only thing that we also need to know about alkenes is there's different types of what we call where a bond can be. So let's erase this down here, or let's move this, just move it a little bit lower. So let's say we have something like this. We'll draw the line formula first. Okay, and then we have 2 substituents here. So let's say that this one ends with an H molecule here, an H molecule here, and then on the ends here we have, let's say, chlorine. So so we'll name this first, and then we'll go over what this means. So let's name it. To name it, oh, we forgot our most important thing, which is our double bond. So to name this, we will first try to figure out what our longest chain is. So we have a carbon here, a carbon here, a carbon here, and a carbon here. So this one would be our longest chain, and it has 4 carbons. So if we go up to our chart, 4 would be bute. Hold on, let me bring Nogops here. She's missing out. So 4 would be bute. So we'll use the prefix bute. And then this has a double bond. So we use the ene prefix. So it's going to be butene. And then we have to identify our substituents. So we have a substituent here and a substituent there. So we're going to number it in order to have the lowest possible substituents. So it doesn't matter what direction we go. We can go 1, 2, 3, 4, or the other way around. They're going to be in the same positions. So we know we have a chlorine at 2 and a chlorine at 3. So what we do in this situation is we say the lowest number, so 2, followed by the bigger number with a dash, and then we state what our substituent is. So I'm just going to move this a little farther. So since we have more than one substituent of the same group, we're going to use di and tri prefixes. So since we have 2 chlorine, we're going to use di. So all we write is di chloro, and then there's no space here, so let's bring this closer, butene. So this would be called dichlorobutene, because there's a chlorine atom here, and there's a chlorine atom here, and then we state that there's 2 of them, what they are, and then the main chain. But what does this mean for alkenes, and why is there's a rule where we have to add one more bit to the name to identify what this is? So if we take a line and we just split it down the middle like that, let's use a dash. We split it down the middle like that. We're gonna see that our chlorine atoms are on opposite sides. On this side we have a chlorine atom and a methyl group. This side we have chlorine atom and another methyl group. So they're on different sides. So this would make it a transalkene. So at the beginning of the name, you do, at the beginning of the name, you'd put trans. And so if we do another example where it would look something like this. Let's do it like this. So if we do something like this where our chlorine atoms are here and then our carbon atoms are over here. Now, if we draw that same line, we're going to see that our carbon atoms are going to be on the same side. So, carbon atoms, same side, chlorine atoms are on that same side. So this would be using the prefix, not trans, it wouldn't use the prefix trans, but it would use the prefix cis. So this one up here, when they are on different sides, is going to be your transalkene. When they are on the same side, it would be your cisalkene. But there's one more thing. What if they are on neither sides? So what if you have something like this, where you have two carbons double bonded, and then you have a chlorine here, and a chlorine here. And then you go ahead and you draw that same line, and you notice, okay, well, I have two here and then I have one here. Is it cis or is it trans? It would be neither. Yeah, so it would just be neither. So it's either trans, where they're on different sides, cis, where they're on both sides, or neither, if none of those two apply. So those are alkanes. So to name them, you figure out what your substituents are, what's your parent chain, and whether it's cis or trans. And then finally, our alkynes. They are very nice and simple. Exact same thing about alkanes and alkynes. The only thing is that the prefix is going to end with "-ine". So this one right here, we just look up here, we see 2F. So this one would just be ethine. And that's all that's needed to know about alkenes. So that's alkenes, alkynes, and alkanes, alkenes, and alkynes. And that's pretty much all you need to know about the basic compounds. So we have our alkanes, which also include cycloalkanes, our alkenes, which also include the cis, trans, or neither prefixes, and then our nice and simple alkynes. So that's all for today's video. Next video, I'll probably talk more about the aromatic compounds, the alcohol, and the more complicated stuff. So yeah.